we were discussing about the GPS signal structure, and I think I've shown you the this figure, which is very important before we discuss or start uh, focusing on detailed aspect. If there is any query in this figure, just you please tell me. So the main purpose of just showing it again is because many of the things you may forget in days to come, but this figure should be in your mind as an image, that your GPS satellite, which is having atomic standard clocks on board, the oscillator of that clock is responsible for generating the fundamental frequency 10.23 megahertz. Clear? So it is the oscillator inside that satellite, which is we also known as atomic clocks. So oscillators of the atomic clocks, it is responsible for generating this 10.23 megahertz. Many times the students forget this, how this fundamental frequency is generated. It is not something which is frequency is always generated by certain equipments. The oscillators, they generate this fundamental frequency. So the fundamental frequency 10.23 megahertz is generated by the your satellite oscillators, and with the help of some multipliers or with the help of some carrier frequency generators, you generate the L1 and L2. The L1 at 1575.42 megahertz, which is having lambda at 19 centimeter, and L2 at 1227.60 megahertz with lambda at 24.4 centimeter. So they generate two kind of carrier. Although at present, as I've told you, there is L5 carrier is also. Okay, there is a M code is also, which is military code. So the purpose of saying is that the foundation or the at the time of GPS, these two fundamental frequency were these two carriers. I'm sorry, these were considered L1 and L2. Then the codes, which we call as the gold codes, very precise code or pseudo random noise codes, PRN codes, are generated with the help of the same fundamental frequency, one by dividing 10 and one by similarly using 10.23. So CA code and P code. So on L1 you have CA code, on L1 you have PY code, but on L2 you do not have CA code, you simply have PY code. Then apart from that, you have navigation message. So just think of a electromagnetic spectrum as a wave, that you have a right-handed circularly polarized carrier wave, which is splitted into two parts. Okay, the right-handed circularly polarized wave is splitted into two parts. Okay, why it is splitted into two parts? Because you have to transfer the P code information also, as the same time you have to also inform the so-called P code also. So how it is modulated, that's the one thing. Okay, so if you properly understand that the right-handed circularly polarized so-called waves, you can always understand that it is, if you take your right hand and you take movement in from your right hand, and on forward motion you make a circular pattern, just like that, it is called as circularly polarized. Okay, so that is the one aspect of the your so-called uh, signal, the carriers, which is right-handed circularly polarized. Again, these are again the same fundamental frequencies derived from all frequencies derived from fundamental frequency. They are all everything. CA code, P code, navigation message, everything is. The other most important aspect which you should not forget is that the CA code has period of 1 millisecond, but the P code repeats after 266 days. That means it is a huge long code of 266 days, and the week long code is allocated to individual satellite. So the periodicity is changed drastically between CA code and P code. The period means when the similar kind of pattern will be repeated. So for CA code, it is repeated after 1 millisecond, just short code, I would say. But for P code, it is a very long code. It is a 266 days code. Okay. And week long code is allocated to individual satellite. These were the properties which I think everyone has seen it. This is the summary that before modulation, the binary state of your code is changed from 0 to 1 to -1 to 1 by using function called 1 minus 2x. Now let us discuss little more about the CA code. So it is a binary state of 0 and 1 pseudo random noise code. Why it is called as pseudo random noise code? Because if you see it that it is 1001, you cannot conclude that why what is the pattern, because it is random. Okay, it is random, totally random. And for unknown user who does not know the GPS or its associated to it, is looked as a noise to them. Okay, so it's a binary pseudo random noise code, PR in quotes, apparently random, although it has been generated by means of a known and hence repeatable process. Although it is generated by certain means of a known method or process, but it is called as pseudo random noise code, consisting of a sequence of 1023 elements with biphase modulation or switch from 0 to 1, also called a chip. Okay, and also used for standard positioning service. So somebody asks you, what are the two kind of GPS services? You will say there are two kind of GPS services. Please remember, I'm telling you about the GPS services. People get confused with codes. There are two popular codes, CA code, P code. There are two types of services. One is standard positioning service and precise positioning service, SPS and PPS. Okay, entire sequence of 1023 chips is repeated 1,000 times each second. This is a very beautiful line. So this is a sequence of 1023 chips which is repeated 1,000 times each second, resulting into chip rate of 1.023 megahertz. That means per second you have 1 million cycles. So the chipping rate, that means at rate at which the chips are being modulated over the carrier, it is 1.023 megahertz. But how it is achieved? It is achieved that entire sequence of 1,023 chips is repeated 1,000 times in each second. So resulting in a chip rate of 1.023 megahertz, or one phase switch every 1 millionth of a second. अब ये जो phase switch word use किया गया है, what do you mean by that? That phase switch means that whenever there is a change from 1 to 0, 0 to 1, 1 to 0, 0 to 1, there is a corresponding chip change of phase in the carrier. Okay, so you imagine in your mind there is a carrier, sinusoidal carrier, and the moment there is a change from 1 to 0, it immediately shift its phase. अभी आप लोग सोच रहे होंगे कि एक शिपिंग रेट तो ये हो गया, कैरियर साइकिल का फ्रीक्वेंसी रेट क्या है? इट्स वेरी लार्ज, इट्स वेरी वेरी लार्ज। अब आप कैरियर का फ्रीक्वेंसी रेट समझिए, इट इज 1575 पॉइंट समथिंग मेगा हर्ट्ज। So it is 1500 times larger than the CA code, and 150th times larger than the P code. That means in each second, that many million cycles of one full wave is repeating every second. That means whenever you modulate chipping rate, means whenever you modulate certain information over it through phase modulation, the phase of carrier wave is shifting. That's it. This is what is the so-called information for CA code modulation. Every satellite carries its own unique code string, which allows for range measurements, access to underlying carrier signal, satellite message, and time marker. That means you need to do the range measurement. So for that, every satellite is providing you a unique code string, which is access to underlying carrier signal, satellite message, and time markers. Chip length corresponds to 293.1 meter in length. Due to code length, ambiguity in measurement with CA code is approximately 293 kilometers. That is, the complete CA code pattern repeats itself every 293 kilometers between the receiver and the satellite. Okay. देखिए यहाँ 293.1 मीटर है, बट इसको जैसे ही आप इससे मल्टीप्लाई करेंगे 1000 टाइम्स से, क्योंकि ये तो एक चिप की बात हो रही है ना, एक चिप की लेंथ, चिप लेंथ, that is one chip correspond to this one, but the whole sequence is this time 1000 times, that is 1023 chips. So when you multiply this by 1000, you will reach somewhere around approximately 293 kilometer, because in 1 kilometer you have 1000 meter. So due to code length, ambiguity in CA code with CA code is approximately 293 kilometer. That means that whole chip length, whole code length is this much. That if you miss the whole chip length, you will create an ambiguity of 293 kilometer. Suppose you have missed the whole code at a time, that is consists of 1023 chips, then means you miss the whole measurement. The complete CA code pattern repeats itself every 293 kilometer between the receiver and the satellite. It's very beautiful line. It's very beautiful line. Any questions?
Sir, why this is repeated 100 times?
To create this 1 megahertz kind of chipping rate. It is repeated 1000 times to create this much chipping rate.
Sir, this 293 meter is the repetition of code length.
No, this is chip length. 293 meter is chip length. That means, see, this 1023 chips are what? 1010011010. So the one individual one or individual zero is of this much length. Okay.
Okay, sir.
Now you can also ask, sir, why this value only? Because there is a calculation behind it. We'll discuss this in the next slide, but this is only one chip. Then the whole code is 1023 chips. That is approximately 293 kilometer in length. Last line is saying that. अब देखिए इसको, अब जो हमने बोला है इतनी देर उसको लिखा गया है, अब इसको आप लोग को फोकस्ड होकर समझना है. आई एम गिविंग यू टाइम टू अंडरस्टैंड दिस फिगर बिकॉज this is the first time you are looking at it. Just observe the figure. So assuming 1.23 megahertz frequency for CA code and repetition rate of 1 millisecond, length of CA code is 10023 bits for chips. For 1023 chips in 1 millisecond, we get a separation of 1 by 1023. That means this is the total chips. So in 1 millisecond, what with the separation? The separation between two chips would be equal to 1 microsecond. Okay. 1 microsecond separation between chips correspond to 300-meter chip length. That is multiplying by obviously the speed of light, you will get somewhere around 300 meter. So we are just focusing at approximation range, not exact. Otherwise, exact would be 293 something. But let's say approximate 1000 if we take, so 1 microsecond separation would be coming nearly about 300-meter chip length. And with the 300-meter chip length, you can achieve resolution in the range measurement up to 1% of the signal wavelength. That means 3 meter. So general rule of thumb says signal processing techniques are able to refine observation resolution to approximately 1% of signal's wavelength. In the case of CA code, the chip length, which translate to about 3 meters, that's theoretically maximum resolution. That is possible by design of CA code. Actual resolution can be considerably higher. Clear? Any questions?
Sir,
Mhm.
so frequency of CA code is 1.023 megahertz is because of their 1023 elements in 1000 time, repeated after 1000 time.
Yes, yes.
Okay.
It is 10023 chips that is repeating for 1000 times in 1 second. That creates that chipping rate, sorry. Similarly, for P code, very long sequence of pseudo-random binary biphase modulation on GPS carrier at a chip rate of 10.23 megahertz, which repeats itself every 267th day. Each 1 week segment of P code is unique to one satellite and is reset each week. Chip length correspond to, since it is one I mean, it is 10th time more chipping range, so chipping length would be reduced to 10th time. That is, one frequency is always inversely proportional to the so-called wavelength. So chip length would be 29.3 meters in length. Carrying two codes on L1 is achieved by phase quadrature. In this process, the unmodulated L1 carrier, unmodulated means nothing has been modulated on carrier yet, is split off and shifted in phase by 90°, then mixed with CA code and then added to the P modulated signal. That means first you split off the unmodulated L1 carrier, then make it shifted in phase difference by 90°, then mixed with CA code and then added to the P modulated signal. So CA code and P codes are rotated by 90° to each other. Epochs of both codes, P and CA codes, are synchronized. In civilian receivers, the short CA code is acquired first to allow the access of the highest precise P code. फर्स्ट लाइन को एक बार पढ़िएगा क्योंकि see if you are reading in the first time na, so every conceptual understanding cannot be just picked up in one single go. You need to go through the content again, but try to give more focus to some elementary concepts so that these basic concepts you should understand, just like some statements, and then followed by you can read more and more later on to strengthen your understanding. Okay. Any question? चलिए, so let us move forward. अब इसका फिगर आएगा, इसके फिगर को देखिए एक बार. Since the chipping rate is more, the chips will looks to you little closer because the frequency rate is very high. See, these are very simple concept. Do not think that these are some very rocket science that we are reading. It's very basic concept. It's just that you are reading it first time. That's it. So just for understanding the resolution concept, here the repetition rate of 1 millisecond has been assumed. Otherwise, the repetition is after 267 days only. Okay. The whole code, whole sequence of P code will repeat after 266 days. But for comparative understanding between CA code and P code, it is assumed that, okay, understand that for time being that there is the kind of assuming repetition rate of 1 millisecond for just for comparison between CA code, P code. Otherwise, repetition of P code happens after 267th day. Or for individual satellite, the week-long code repeats after 1 week. For 10230 chips in 1 millisecond, we get separation of 1 milli divided by 1 millisecond divided by 10,230 chips, which makes it to 30-meter chip length. And individual chip, which is corresponding to 30 meter, you take resolution of 1% of the signal wavelength. That makes it to 0.3 meter. Now understand this part. One thing is for range measurement between satellite to receiver, you have CA code. You can take the range measurement with the help of CA code. You can take the range measurement with the help of P code, but there are two other codes also through which you can go for range measurement. Another thing is carriers. You can take help from the carriers. So ranging accuracies, range resolution or codes, which is P code spectrum, has a bandwidth of 20 megahertz, which correspond to a resolution of 1 nanosecond. That is 30 centimeter for good signal to noise ratio. CA code spectrum has a bandwidth of 2 megahertz, which correspond to a resolution of 10 nanosecond. That is 300 centimeter for good signal to noise ratio. Bandwidth means difference of higher frequency domain to lower frequency domain. That creates the bandwidth. In that width, your signal is traveling. Your P code spectrum is traveling. So the bandwidth is given to consider a good signal to noise ratio till the signal reaches to your receiver. अब आप कैरियर फेस के रेजोल्यूशन को देखिए 1.9 mm बिकॉज 1% ऑफ द वेवलेंथ इज 19 सेंटीमीटर का 1% करिए दैट गोस अप टू समवेयर अराउंड 1.9 मिलीमीटर। और अगर आप एल का करेंगे L2 का तो 2.4 मिलीमीटर। So when we say that it is 1.9 mm or 2.4 mm, so when we say the GPS is giving us the millimeter level kind of precision, so it is in fact the carrier waves that are helping us in achieving the millimeter level precision. Okay, it is not the codes, it is the carrier waves which are helping us. Here we are reading about the GPS signal structure format. It's very simple code, very simple figure. If you understand it, it's very good. See, this is the summary of what we have discussed. This is the oscillator. Okay, this is your oscillator. This is creating fundamental frequency. From fundamental frequency, you are generating L1, CA code, P code, L2. So everything is written F0, 0.1 F0, 154 F0, 120 F0. And this is the data signal, navigational data message at 50 BPS. Okay. Carrier is written as A1 sine omega 1t. What do you mean by A1? Amplitude of L1. Sine, sinusoidal signal. Omega 1, that frequency. And time, with respect to time, how it is changing. Then you split it. The code, the signal is split into two parts. One at 90-degree phase shift, you generated the so-called splitted signal into two parts. Why? Because you have to modulate the CA code. So first, navigation message is having modulo 2 addition with the CA code and P code. You could see it here. This is navigation message. This is going and having modulo 2 addition with C code, D code, and CA code and P code. Now the signal becomes DTCT. That goes and have again modulated over this carrier. Splitted carrier becomes AC DTCT cos omega t. Here, since it is having 90-degree phase shift, so sine 90 plus phi is cos phi. Okay. Then P code is again used as modulated over L2, and other part is modulated over so-called what should I say, the part of the replica of L1. So it becomes A1 AP DT PT sine omega 1 t. Just like it is written AC DT CT cos omega t, the P code which is going up is written here. We could write it also, or in fact it is written here AP PI DI sine omega t plus AC CI DI cos omega t. This is final signal that is being transmitted from satellite. अब I represent satellite number. SL1, L1 signal with modulated P and CA code. SL2, L2 signal with modulated P code. AP, amplitude of the P code on L1. AC, amplitude of the CA code. BP, P code amplitude on L2. PI, P code sequence with state plus minus 1. CI, CA code sequence with plus minus 1. DI, data stream with rate plus minus. A sin omega t is carrier signal. Everything is written. Just take a look. Just let me know if you have any confusion. Just let me know.
Sir, sir,
Yes.
sir, we have read that L1 signal gets split into two, one with 90-degree phase difference, and then this 90-degree phase difference gets overlapped with CA code.
Hmm.
Yes, sir. Sir, but what is this data signal 50 BPS which is coming towards CA and
This
then
is
combining?
navigation message. As I've told you, navigation message has a lower chip rate because it has a very large information that has to be transmitted about satellite orbit and the various perturbation forces that is acting over it in terms of numerical values. So it is like a small book. Have you seen is the small pocket Bhagavad Gita kind of thing? So it is that kind of small pocket of information that is being transmitted. So it is modulo to addition having with both CA code as well as P code because it has to be transmitted through L1 also as well as L2 also.
Okay, sir.
Any more question because others are not participating? Yeah, it seems that everything is clear to them.
Sir, we read that L2 carrier contains only CA code. Then, sir, why PY code is coming towards L2 carrier?
Huh?
Sir, we have read that L2 carrier contains only CA code.
Huh. L2 is containing
Then,
only P code, not CA code. L2 is containing only P code.
okay, sir.
Any more question? Another bit of information for you purpose. Just look at it. figure is important in terms of the above information is from satellite, the signal from the satellite end, and the below is receiver processing, how receiver process it.
सर थोड़ा जूम कर दीजिए प्लीज.
मोबाइल में देख रहे हो क्या?
यस सर.
अरे यार मोबाइल नहीं, थोड़ा सा लैपटॉप पे देखा करिए, सीरियस होके थोड़ा सा एमटेक की पढ़ाई करिए. मशीन है, डेस्कटॉप है, आप उसका यूज करिए. चलिए, if there is no question, तो ST is CA code waveform, let's say. For example, it is, let's say ST is CA code waveform, not P code, सिर्फ CA code waveform. Then S represents the signal power, D represents the 50 bit per second data stream, CA represents the CA code, omega represents the L1 carrier frequency, phi represents the phase. At receiver end, since it is a weak signal that has been received by the receiver, amplify S for easy processing, demodulate to strip off the data, track the CA code to get the pseudo range, and then track the carrier to get the delta pseudo range, which is the Doppler information, phase shift in the frequency. So these are the carrier signal which is right-handed circularly polarized. This is example of P code. This is CA code. So it is 6 into 10 to power 12 bits per satellite, 7 days. CA code 1023 bits per satellite. इसीलिए आप देखिए यहाँ पर 0.001 सेकेंड लिखा है, बट यहाँ नहीं लिखा है क्योंकि रिपीटिशन रेट 7 डेज के बाद होता है फॉर पर सेटेलाइट. होल कोड विल बी रिपीटेड आफ्टर 267 डेज. हालांकि होल कोड के रिपीटिशन का कोई मीनिंग नहीं है, बिकॉज सिंस इट इज allocated to week wise to each satellite, then the whole code repetition doesn't have any understanding. Okay. तो अब चूंकि फेज शिफ्ट की मॉड्यूलेशन हो रहा है, इट इज नॉट टू स्केल, so do not worry that whether it is not reflecting in the P code. So let's say this is CA code, so this 1 converted to 0, phase shift happened. It should have gone like this, but phase shift of 180 degree. Then similar to this, the whole signal is being prepared accordingly. Any questions in that?
सर ये जो सीए कोड का दो डायग्राम है, एक में 1 और 0 करके है और दूसरा जो साइनसॉइडल वाला है, सर इन दोनों डायग्राम्स में कोई रिलेशन है आपस में?
कौन सा?
सर थर्ड और फोर्थ वाले में जो सीए कोड के बाद है.
हाँ, वो तो पहला तो फेज शिफ्ट की मॉड्यूलेशन समझाया गया है. The first one, third one, sorry, this one. No, sorry, this is the fourth one, na? हाँ, first, second, third, fourth. The fourth one is representing how the modulation has happened.
Yes,
for let's say for example CA code. P code के लिए होता तो इसी के छोटे वर्जन को दिखाते हैं. यहाँ से 1 से 0 है तो यहाँ शिफ्ट चेंज होगा, फिर यहाँ चेंज होगा, फिर यहाँ चेंज होगा, फिर सेम रहेगा, फिर यहाँ चेंज होगा, फिर यहाँ चेंज होगा, फिर सेम रहेगा, फिर यहाँ चेंज होगा, ऐसे. तो उन्होंने नॉट टू स्केल करके सिंपल 101 का दिखा दिया. अब लास्ट वाला जो है
सर जो
हाँ
सर जो थर्ड वाला है सर, उसमें पहले तो 1 है फिर 0 है. तो सर जब 0 है तब भी क्यों फोर्थ वाले में सिग्नल आ रहा है?
नहीं, 0 पे बेटा 0 का मतलब सिग्नल नहीं आना नहीं हुआ. 0 का मतलब ये हुआ कि स्टेट चेंज हुई. पहले तो 1-0 को स्टेट चेंज की जाती है, 1 और -1. इफ 1-0-1 है तो उसकी स्टेट चेंज की गई 1-2x से 1 and -1. ठीक है. अब whenever there is a change between 1 and -1, the phase of the carrier signal will be shifted to 180 degree.
Okay sir.
हाँ, तो नॉट टू स्केल का मतलब ये बताया गया, सपोज एक के, और मैंने आपको बताया ही हुआ है कि आपका ये तो 1 है ना, 1.023 मेगाहर्ट्ज, कैरियर वेव कितना है 1575 मेगाहर्ट्ज, यानी कि जब जब इसकी एक साइकिल चल रही है, 1 मिलियन साइकिल चल रही है पर सेकेंड, उसकी 1575 मिलियन साइकिल चल रही पर सेकेंड, यानी कि जब इसका एक आएगा तब उसकी 1500 आ जाएंगी साइकिल्स। तो फेज शिफ्ट तो वहीं पे दिखाई देगी ना जहां पर 1 to 0 का कन्वर्जन है, हियर। फिर बीच में कुछ नहीं होगा, फिर जब 0 से 1 की शिफ्ट होगी तो वहां चेंज होगा। यू गेटिंग इट?
Yes, sir.
So special features of signals is Department of Defense has established a policy for implementation of selective availability and anti-spoofing for GPS signal to limit. So these are the two types of special features, selective availability and anti-spoofing, to limit number of unauthorized users and level of accuracy for non-military applications. Okay, so selective availability causes degradation in positioning performance by degrading the orbital information or signal frequency in general. That complicates the solution strategy, that is use of DGPS. Anti-spoofing is P codes gets encrypted by adding modulo to some of a W code, which results in Y code, not known to civilian users. एक बार आप देख लीजिए कंटेंट। I'm sharing the first quiz exam options. So you see your just a moment. चलिए थोड़ा सा आगे बढ़ते हैं फिर बात करते हैं. So what about the anti-spoofing? So potential enemy might interfere with US military operations by transmitting a false GPS signal that overwrites the GPS signal, the real GPS signal. That may happen. Overwrite means that will represent as a true GPS signal. In fact, it is a false signal. So anti-spoofing says that you can encrypt the P code with both on both L1 and L2 to convert into PY code, making it useless to anyone who doesn't have proper decryption keys. Only authorized users have access with decryption keys. Okay. So it is something which is saying that you decrypt the original code. First you encrypt it and then decrypt it. So CA code, however, would not be affected if a hostile did implement some form of signal spoofing. Users of CA code would not be able to compensate for it. मतलब अगर कर देता है कोई स्पूफिंग सीए कोड के लिए तो फिर उसके लिए कोई कंपनसेशन नहीं है. Very expensive civilian P code receivers available. Manufacturers have developed proprietary receiver software combinations that can see through the encryption by reconstructing the code using various techniques that are product specific. Their advantage is that they retain high accuracy over very long baselines. The military has exclusive access to PY code. So basic summary ये है that P code is nothing but encrypted with some W code to make it a Y code. It looked as a P code, but it is different than P code. Just to make sure that nobody can recreate the original P code if it is available in the public domain. Only authorized user who have this receiver software combinations that can see through the encryption by reconstructing the codes using various techniques. The military has exclusive access to PY code receivers, which include direct decryption capabilities. So GPS user hardware must have ability to track and obtain any selected GPS satellite signal. A receiver will be required to track a number of satellites at a time in the presence of considerable ambient noises. This is now possible because of the spread spectrum and pseudo range noise coding techniques. The spread spectrum ratio was almost exclusively used by military until 1985, pardon, when FCC allowed spread spectrum unlicensed commercial use. The SSR differs from other commercial radio techniques because it spreads rather than concentrate its signal over a wide frequency range within its assigned bands. The key characteristic is that they increase the bandwidth of a transmitted signal by significantly large ratio to original signal bandwidth. So these are some key characteristics. How the signal spreading techniques are used? They are called as direct sequencing and frequency hopping. Hop and hop on, hop off kind of buses are there in the foreign countries. In fact, in Bombay also it is like that. You can board some buses, deboard some buses to visit some local places, then again come again and board some place. So in the frequency hopping also, the signal is keep switching between the different channels so that nobody have access to the complete code if it is tracking only a particular band. Okay. So direct sequencing continuously distributes the data signal across a broad portion of the frequency band. It modulates a carrier by digital code with a bit rate much higher than the information signal bandwidth. Alternatively, frequency hopping radios move a radio signal from frequency to frequency within a fraction of a second. A spread spectrum receiver has to reconstruct the original modulating signal from the spread bandwidth signal by a process called correlation. It's a very important phenomenon. I'll explain in detail about this. The fact that the interference remains spread across a large bandwidth allows the receiver to filter out most of their signal energy by selectively allowing through only the bandwidth needed for the despread wanted signal. See, the correlation phenomena is a very popular phenomena where you try to correlate with the signals between two signals. Okay, so a spread spectrum receiver has to reconstruct the original modulating signal from the spread bandwidth signal by a process called correlation. तो आप क्या कर रहे हैं, आपके पास जो original signal that is coming from the satellite, you are trying to create a replica inside that receiver, and then you try to find a correlation between these two. And since every satellite has a unique gold code, that receiver knows it can generate a replica of the signal coming from satellite. That process of correlating the two signal, one is the original, another one is the replica, is called correlation or called autocorrelation. Okay. Next topic is navigational message. Navigational message includes information on satellite time of transmission, satellite position, satellite health, satellite clock, propagation delay, time transfer to UTC, constellation status. Each satellite sends ephemeris information, that is a full and precise description of its own orbit and clock data, almanac information, an approximate guide to the orbits of the other satellites, other parameters, which is representing satellite clock corrections and the delay caused by signal propagation through the ionosphere. Accuracy of some aspect included in navigation message deteriorate with time, which are updated by certain renewal mechanism with the help of control segment. So the navigation message is, it is a navigation message includes information on, again, satellite time of transmission, satellite position, satellite health, clock, propagation delay, time transfer to UTC, constellation status. In summary, the three information are available. One is ephemeris information, another is almanac information, another is parameters, other parameters required for identifying the satellite clock correction and medium delay information. So as I've told you, navigation message is just like a pocket Gita or pocket diary kind of thing, which has on every pages you have information. Similar to that, you have this structure of navigation message. This is the structure. You just see. So navigation message have a master frame, which includes all 25 pages of subframe 4 and 5. That is total 37,500 bits. One frame, which is 5 subframe. One subframe, 10 words. Each word, 30 bits. Transmission rate, 50 bps. That takes total time of 12.5 minutes to transfer whole message. So you have one frame that consists of 5 subframe. Okay, that individual frame has 5 subframe. Each subframe has 10 words. Each word is of 30 bits. That figure is representing plus, including all 25 pages of subframe 4 and 5. So one master frame includes all 25 pages of subframe 4 and 5. That makes it 37,500 bits, taking 12.5 minutes when you have chipping rate or transmission rate is of 50 bps, bits per second. How? You can have this information. You can divide 37,500 by 50 bps, you will get 750. You divide 750 by 60, you will get 12.5 minutes. That's it. Just have a little reading on the bottom. You just take one to reduce the time it takes to obtain an initial position, the ephemeris, the satellite position, and orbital information and clock data is repeated every 30 seconds. Although the initial first information, which takes a lot of time in transmitting, but that keeps changing. If you access the information, that navigation file, you have that every second, every 30 seconds, you have information that is available to you. We'll show you one navigation file also in laboratory. देखिए स्ट्रक्चर देखिए एक बार कि in first 30 second you have TLM handover word clock correction, TLM handover FRS parameter, TLM handover ephemeris parameter, TLM handover almanac ionospheric model DUTC, TLM handover and almanac. Then it keeps repeating in half a minute, 1 minute, and so on. So every 30 seconds you have this much information. Okay. So each subframe containing 300 bits lasts 6 seconds. Subframe 1, 2, 3 repeats every 30 seconds, while subframe 4 and 5 have 25 version before repeating. The entire navigation message repeats after 12 points. So आप अगर आप 12.5 मिनट के लिए रिसीवर ऑन करते हैं, डेटा ले रहे होते हैं, तो एक नेविगेशन फाइल आपको 12.5 मिनट के बाद दूसरी फाइल मिल जाएगी. तो आपके पास अगर आप प्रिसाइजली डेटा ले रहे हैं और बहुत छोटा डेटा ले रहे हैं, तो हो सकता है आपको एक ही नेविगेशन फाइल में आपका काम हो जाए. हालांकि once you read any navigation file, then only you understand the different words. Otherwise, if you do not read any file, then possibility is that you do not pick up the different or even you do not need any navigation file. You just simply have to use it. That is the beauty. If you want to read the details, it's okay. If you do want, if you just want to use it, that's also okay. Navigation message has 5 subframe, 1, 2, 3, 4, 5. Everything is written. So it has TLM. The first word is telemetry word, contains a synchronization pattern which facilitate access to navigation data. That means once somebody is knocking on the door, that has some synchronization pattern, only after which you can access the whole data. Then the second word is handover word. It contains time synchronization information for transfer from CA code to P code, allows direct access to PRN codes. The first CA code must be acquired, allowing access to handover word from the navigation message, and then P code can be acquired. Since CA code, which is allowing then access to navigation message, that is handover word, allows for time synchronization. अब आप लोग कह रहे होंगे टाइम सिंक्रोनाइजेशन का मतलब क्या हुआ भाई GPS doesn't work in our clock system, that's it. It has its own clock that is running at Sunday midnight to next Sunday midnight. That is the whole 7 day of working. It doesn't understand Monday, Tuesday, Wednesday. It doesn't understand what is the time you are. It is simply have its own running time system through which it is measuring the time synchronization. So suppose you are switching on your receiver on Wednesday. It doesn't know if it is Wednesday or not. It is simply counting from Sunday midnight to another Sunday midnight to make it full 1 week. So let's say you have switched on the receiver on Wednesday. It simply accesses the CA code first, then the navigation message. The navigation message, handover word. A handover word is again, it's a truncated Z count information is available. So what it does, it tries to estimate is that where you are in that Wednesday. For GPS, it is the third day from the week of this segment. So which is started at Sunday midnight. So for GPS, it is the third day of that week. For you, it is Wednesday, but for them, it is third day of the GPS week. To reach the third day, they need certain time synchronization. So the moment you switch on, CA code has started correlating little bit of initial time before you acquire signal. The moment CA code is started correlating, you can access to the navigation message, because CA code will tell you that it is from which satellite you are getting the information. And then once you access the initial few information of the navigation message, you can reach to handover word, which will transfer you to the exact segment of the P code of that particular day. where you can again start correlation between the P codes. Initially, you were doing for CA code to get an estimate of the range, but then you need P code to have little more so-called precise range measurement, and then you move from CA to P code with the help of this handover word. So P code can be accessed only after occurrence of CA code, supported receiver, time synchronization with GPS time through Z count. Handover word contains so-called Z count, an integer number of 1.5 second period since the beginning of the GPS week, and thus identifies epoch of the data record in GPS time. Knowing Z count, one can acquire the P code within next 6 seconds. So it is a chain of event that is taking place. There is nothing rocket science behind it. It is a process that has been followed. Okay. So with this, we stop here. It is too much content for you to grasp right now. What you can do, you can read up to navigation message, and on Tuesday, we will have a quiz up to this point. So it will give you a little more time for 3-4 days to read the content, understand the content, have your queries, and don't worry. It will be you who will read this navigation file from your own MATLAB code. There is no need to worry about it. It is just that you need to understand the concept a little bit. You will learn reading the files. You will learn reading, developing the codes for again finding the satellite coordinates. So it will be just a task. There is no need to worry about it. Any questions?